It is given that a stone with weight W is thrown vertically upward into the air with the initial speed of v0. If a constant force F due to air drag act on the stone throughout its flight, then first one is show that the maximum height reached by the stone H is equal to. So over here we know that if we are throwing an object in upward direction with some initial velocity taken as v0, as it is moving in upward direction, air drag is exerting a force F, or it is doing a negative work, and gravity is exerting some force in downward direction. So over here because of this negative work which is done by non-conservative force, there will be some decrease in its energy. So over here if you are using the concept that total energy final is equal to total energy initial minus what about the value of this work done by non-conservative force. So total energy final, as it is reaching a height h, we can write final energy is going to be m into g into h is equal to total energy initial was its kinetic energy, that is half into m into v naught square minus work done by this frictional force or the resistance force, as work done is force into displacement and it is traveled by a height, let's say h. So we can write this work done will be equal to F into h. As the force and displacements are in opposite direction, we can write work done is basically negative, that's why we are writing minus F into h over here. So we can calculate what about the value of h over here. So if you are taking this mg into h, if you are taking this h as common, mg plus F is equal to half into m into v naught square, or you can write the value of h is equal to half into m into v naught square divided by mg plus F. And this mg is basically representing the weight, so Rm is to represent in terms of weight, so we can write as half into m into v naught square divided by, instead of mg we can write as w plus F, which is equal to, if you are taking this w outside, so we'll get as it is half into m into v naught square divided by w into 1 plus F divided by w. Now if you are taking this, if you are writing this w as m into g, so we can write it as half into m into v naught square divided by mg into 1 plus F divided by w. So we can cancel this m. So this h is going to be half into v naught square divided by g into 1 plus F divided by w. Now on the second part, our aim is to find out, show that the speed of sound upon impact with the ground is. So as it is hitting the ground, so what about the velocity with which this is going to hit the ground? So initially it is moving in upward direction, then velocity becomes 0, then it is start moving in downward direction, and initially it is projected with a velocity v0, and assume that finally it is going to hit the ground with a velocity v. So basically our aim is to find out the value of v over here. So again, if you are using the same equation, total energy final is equal to total energy initial plus work which is done by the non-conservative force. So total energy final is nothing but its kinetic energy, half into m into v square. Total energy initial is its initial kinetic energy, that is half into m into v naught square plus work done. So over here when the object is moving in upward direction, then frictional force is going to act in downward direction, and if the object is moving in this downward direction, then this frictional force is going to move in upward direction. So always this frictional force is doing a work which is opposite to the direction of displacement. So work done by that frictional forces or resistance force is always negative. So total work done will be force into displacement, force is F, into total distance is traveling is 2h, h upward and h downward. So we can write this total work done will be minus 2h into F. So basically we can find out what about the value of this velocity v with which it is hitting the ground. So for velocity v we can write this half into m into v square is equal to half into m into v naught square minus 2 into h into. Our aim is to write this in terms of not in terms of h, so we can just substitute the value of h over here. We know that the value of h was nothing but m into v square or v naught square divided by 2 into w plus f. So we can write, so if we are cancelling this m, so we can write and multiplying with 2, we can write v square is equal to v naught square minus 2f v naught square divided by w plus f. So if you are taking this v naught square as common, it is w plus f minus 2f divided by w plus f, which is this v square is equal to v naught square into w minus f divided by w plus f. So we can write the value of v will be equal to v naught into under root of w plus w minus f divided by w plus f.